Hello students, I am Mr. Adinath D. Badar, Assistant Professor, Department of Chemistry, Late Pushpadevi Patil, Arts and Science College, Resort, Dist, Worship. Today in this video lecture, we will discuss the topic coordination compound. So firstly we see the contents of this unit or fine points of this unit. So first point is important terms used in coordination chemistry. Second point is Werner's theory of coordination compound. EAN effective atomic number or 18 electron or Sidgwick's concept for complexes. Nomenclature of coordination compound. Isomerism in coordination compound. So firstly we start the important terms used in coordination chemistry. Important terms used in coordination chemistry. So first term is molecular, or it is also called addition compound. Molecular or addition compound. So simply when a solution containing two or more salt in simple molecular proportion are allowed to evaporate, a crystal of new compounds separate out. These separated compound called as molecular or addition compound. The separated compound have different shape, size and chemical properties to the parent salt depending upon their behavior in aqueous media or nature in aqueous media or any other solvent. The molecular or addition compounds are further divided into two classes, that is double salt or complex compound. Double salt or complex compound. For example, we mix A plus B, that is 2 salt, gives third salt, that is C. This C may be double salt or complex compound depending upon the nature of C in aqueous media. So we will discuss what is double salt and what is complex compound. So firstly we see what is a double salt. So simply those molecular compound exist only in crystalline state, that is only in solid state, but break down in their parent constituent when dissolved in liquid or any other solvent. They show their chemical properties as like parent salt. For example, here the first example is Mohr salt, that is FAS, also called as FAS, ferrous ammonium sulfate or ammonium iron second sulfate. Another example is potash alum. Potash alum. The third example is carnallite. So we will discuss the first example, that is Mohr salt. For example, here FeSO4 plus NH4 by 2 SO4, that is ferrous sulfate plus ammonium sulfate gives ferrous ammonium sulfate in solid state. In solid state, this compound shows different properties to that of parent salt. But when we mix this ferrous ammonium sulfate in aqueous media or any other media, it gives each ion test, that is Fe plus 2, SO4 2 minus and NH4 plus, that is ammonium ion, means it is breakdown in a liquid state, that is this type of compound is called as double salt. For example, here FeSO4 is mixed in aqueous media gives Fe plus 2 plus SO4 2 minus, as like same ammonium sulfate mixed in aqueous media to gives twice NH4 plus SO4 2 minus as like same parent salt. This compound is also shows the positive test each and every ion present in this parent compound. Then this type of compound is called as double salt. Then next we will see what is mean by coordination compound. So those molecular compounds retain their identity even dissolve in water or any other solvent. They show their chemical properties completely different to the parent constituent. For example, nickel chloride plus ammonia to gives hexaamine nickel second chloride in the solid state. When we are dissolve this compound, it does not show test positive as like parent compound. This is the final compound and the nickel chloride shows Ni plus 2 plus twice Cl minus. Then next, what is the difference between double salt and complex compound? So here this diagram clearly shows what is the difference between double salt and complex compound. So double salt, they are addition compound. Complex compound, they are also addition compound. Their crystal have definite geometrical shape. They have their own stereochemistry depending upon the hybridization of metal ion. For example, octahedral, tetrahedral as like they retain original bonding as like parent compound. In the complex compound, a new types of bond are formed between metal and ligand, that is cation or anion, that is called as coordination bond. They are crystalline in nature. They may or may not crystalline. In aqueous solution, they give positive test of each ion present in parent compound. In aqueous solution, they do not give positive test of each ion present in a parent compound. Then the next terms is central metal ion. What is the central metal ion or also called as CMI? It is a positive metal ion, that is cation, having two or more neutral molecules or negative ions or very rarely positive ions attached to it in a complex. So this is the definition of central metal ion. For example, here in this complex, Ni is a metal carries positive charge, that is cation, and hence these are the central metal ion and these ammonia are the ligand. So next definition is what is ligand. The group attached or the group is directly attached to the central metal ion called as ligand. They contain at least one electron pair for the purpose to donate to the central metal ion. They contain at least one electron pair for the purpose to donate to the central metal ion. These ligands are further classified as unidentate, bi, tri, tetra or polydentate depending upon the number of donor site. The details of classification of ligands we will see the part B of unit first in chelates. So next definition is coordination number. So it is the total number of coordinated bond that central metal ion form or total number of group or ligands directly attached to the central metal ion. Simply, it is the total number of coordinate bond that central metal ion form or total number of group is directly attached to the central metal ion. For example, in this example, hexaamine nickel second chloride, the 6 ammonia molecule are directly attached to the nickel. Then the coordination number of this complex is 6. Here the 6 cyanide ligands are directly attached to the iron. Then the coordination number of this complex is 6. Here the 5 ammonia and 1 chlorine ligands are directly attached to the cobalt. Then the coordination number is equal to 5 plus 1 is equal to 6. Another term is complex ion. An electrical charge complex having central metal ion and 2 or more ligand is called as complex ion. The charge carried by complex ion is algebraic sum of charges of central metal ion and ligand. For example, in this first example, hexacyanoferrate, the iron carries plus 2 oxidation state or more stable oxidation state is plus 2, then iron carry plus 2 charge, each cyanide carry minus 1 charge. Here number of cyanide is 6, then minus 6, so plus 2 minus 6 is equal to minus 4. That is the charge on complex ion. Here another example, here ammonia is a neutral ligand, so charge is equal to 0, but the most stable oxidation state of cobalt is plus 3 and chlorine carries minus 1 charge, so plus 3 minus 1 is equal to plus 2. That is the complex charge, algebraic sum of charges of central metal ion and ligand. In the last example, here platinum shows most stable oxidation state is plus 4. So here ammonia is a neutral ligand having 0 charge, but each bromine carry minus 1 charge. So here 2 bromine means minus 2 and the platinum carries plus 4. So plus 4 minus 2 is equal to term is complex compound. A compound containing complex ion are called complex compound. Sometimes the coordination compounds does not contain any ion and this is called as neutral complex compounds or anionic complex compound. For example, this example that is cisplatin. Here the platinum carries plus 2 charge. This 1 chlorine carries minus 1 charge. Here number of chlorine is equal to 2 means twice minus, and this ammonia carries 0 charge, that is neutral ligand. So plus 2 is equal to minus 2. The total charge on this complex is equal to 0 and this type of complexes is called neutral complexes or non-ionic complexes. The second term is coordination sphere. The sphere having central metal ion and number of ligand attached to it called as coordination sphere. During the writing the formula, the group present in coordination sphere are always enclosed in square bracket. Here these diagrams clearly shows each and every terms used in coordination compound. For example, here the inside moiety of this square bracket is called as coordination sphere. These cobalt are central ion and this chlorine and this ammonia are directly attached to the cobalt, then it is called ligand. The total number of ligand is this chlorine and this 4 molecule of ammonia, 4 plus 2, that is the coordination number is equal to 6. This Cl minus here is called the clarification of important terms, that is, for example, the complex compound K2PtCl6. Here the complex ion, that is the moiety inside the square bracket, that is PtCl6 minus 2. Here the central metal ion is platinum plus 4. Here the ligand is chlorine. The number of ligand is 6, then 6Cl minus, and the coordination number is also 6. In the another example, CuNH3 by 4 SO4. Here the complex ion is CuNH3 by 4 plus 2. Here the central metal ion is copper plus 2. This copper plus 2 is central metal ion. The ligand is 4NH3, that is 4 mole of ammonia, and number of ligand is 4, then the coordination number is 4. Here COCl2 NH3 by 4 Cl. Here the complex ion is COCl2 NH3 by 4 plus. Here the central metal ion is cobalt. Here the ligand is 2Cl and 4NH3, that is 2Cl and 4NH3. The total number of ligand is attached is 2 plus 4, that is the coordination number is 6. Here K3FeC2O4 by 3. This is the bidentate ligand, oxalate bidentate ligand. Here complex ion is FeC2O4 by 3, that is 3 minus. Here central metal ion is Fe plus 3. Ligand is 3 mole of C2O4 2 minus, that is oxalate, or this ligand is called as bidentate. Each ligand form two coordinate bond to the central metal ion, then it is called bidentate ligand. The number of ligand is 3. Each ligand form 2 bond, that is 3 into 2, that is the coordination number is equal to 6.